Without further ado, let me introduce the speakers tonight. Dr. Alfredo Carpineti is a gay Italian astrophysicist, a science journalist, and also a social activist. He's the chair and founder of Pride in STEM, an award-nominated British charitable trust, and he was also recognized as one of the 100 LGBTQ trailblazers by Attitude magazine. He's the senior space correspondent for IFLScience, and he blogs, vlogs, and podcasts as the Astroholic. Also, his husband, Chris Carpineti, is a video editor who loves to make videos and podcasts, both in STEM for IFLScience and Pride in STEM, and also in his free time for his personal projects. He's the other half of the Astronomy podcast, the Astroholic Explains, and the creator of Raidercast, the leading podcast for the Tomb Raider video game series. So please welcome the Carpinetis.
Chris has changed his surname this year, and I think this is the first time they've been introduced as the Carpinetis.
It is.
It's good
Yeah,
sound.
thank you.
So the first half of the talk we're gonna record it and we're gonna post it as a podcast for Astroholic Explain, and it's gonna be a video on the Central London Humanists YouTube channel. So that's very exciting.
Yep.
So welcome to the Astroholic Explain live.
This is the first time we have done this podcast in this format. It's the first time I've ever done anything like this, so if I start speaking very quietly, please shout at me. And yeah, shall we start?
Yeah, the format is very simple. Chris asks me questions and I need to answer them.
Yeah, so as was said, I'm not a scientist, but I'm interested in science, and so he has hopefully more answers than I could hope to fathom myself. And yeah, would you like to start?
Let's start.
Cool. Okay, so everyone who's here today has probably read the flyer. I'm going to ask you today a bit of a controversial question in some circles. How is astronomy used to prove or disprove the existence of God?
In so many ways, the relationship between divinity, and we're not just talking about religion, but any kind of approach to how we understand deity and supernatural and beyond life is deeply intertwined with astronomy. Astronomy is the oldest science, and we need to consider its origin as a way to explain not just what was happening in the sky, but also what was happening on Earth. And we cannot even pretend, even if we just take the most modern aspect of religion, that they're not based on the astronomy and astrology of ancient. From the day in which Christmas and Easter fall to, everything that has been fought over the last 400 years between the science and major religion. But even just considering the constellation that we consider in the northern sky, they're all based on Greek-Roman myths. So again, we see religion in there. And it's so fundamental that there's been always this push between, in religion to use astronomy and astrology to sort of explain the universe, but also once the answer weren't the one that they were looking for, to completely reject it. But it's fascinating that there is always this push that people always, we're not just talking about, Galileo, Giordano Bruno, we'll touch that, but something that I always find fascinating is, until pretty much very modern time, astronomy and astrology were synonyms. But the church, the Catholic Church, hated astrology. They saw it as paganism, they saw it as superstition, and they saw it as something that it was blasphemous.
I find that quite interesting. Sorry to interrupt.
Yep.
I find it quite interesting as well because, like, one of the earliest examples people tend to be taught in in growing up, I suppose, is the three wise men.
Yeah.
They followed a star. They literally they used astronomy to find the savior.
But it's not just that they use astronomy. In a way, they also use astrology, because they were one and the same. They were looking at the night sky, hoping for answers. And we're still doing that. We know that the position of planets and constellation doesn't affect our lives, but we're still looking at the cosmos to understand why we're here. But on the astrology front is the fact that the Catholic Church, which is an incredibly powerful institution, has not been able to sort of crash it. And ruler would sort of fund astronomy, and a lot of the astronomy that then was crucial to the scientific revolution was funded because the astronomer were also doing horoscopes. And it's scientists do the worst things just to get money to do their science. But it is very fascinating that despite that there is obviously the star Bethlehem, Easter is we pick Easter based on the first moon of spring, which is just like it's shouting paganism like so loudly. It's just like, this is a fertility ritual. And like, why we have chocolate and eggs and bunnies that lays eggs? That is, it is the paganism, but it's the fact that
there's a strange myth there, I think.
It is the fact that Catholic Church, I thought, it's actually easier to just convince and take over in a way that is okay for us to just mix all this together. And it's very, they cannot just quash it. And it's the same with Christmas. We light candles, we use fir, we do rites that are celebration of the solstice, a celebration of the light returning into the year. And it's just that sometimes it's easier to join them instead of fighting them. Sometimes it's not. And we have the case of Giordano Bruno, who was burned at the stake by the Inquisition. And one of the things that was most heretical from him was his idea that out there in the universe there were an infinite number of planets. And for us, it's just like, oh yeah, we're seeing so many planets now. We think that there is a planet around almost any stars, and there are 100 billion stars in our Milky Way alone, in our galaxy alone.
Was he one of the first to question, what if we are not the center of the universe?
No, there's been plenty of questioning that. His discussion was more philosophical, but it was just like, oh, no, you're going to burn at the stake, because that would put the entire doctrine of the church in question. And then we have 100 and so years later, we have the trial of Galileo, and he approached it in a completely still philosophical way, just like pointing out all the flaws of Greek philosophy that the church just assumed. And one of the things that bothers me the most, so
here we go.
Yes, here's the first round of the evening. So Inquisition ended officially, I think, 1750, but it's sort of been always re-updated, and in the 20th century became the office of what's it in English? Of the doctrine of the faith. One of the leader of that was a cardinal by the name of Joseph Ratzinger, who you may know as Pope Benedict XVI, who, when the church was actually dealing with Galileo's case, and just like, maybe it's the 1990s, maybe we should deal something, he pretty much said that Galileo, it was Galileo's fault that he was condemned by the church, because he didn't make his case well enough for the church to believe. And
so, if he's such a big scientist and he's such a big name and everyone knows of Galileo, but it's the church. Like, what kind of evidence could he possibly have given them to make them completely be like, oh, right, you're right? Like, he was doomed.
Oh, absolutely. That is absolutely that is absolutely the issue.
I mean, it's today. That's an ongoing thing, surely.
It's a no-win game.
No.
Like, it wasn't set up for a fair trial.
No.
But it's what bothers me the most about the whole modern Galileo affair, and especially Ratzinger, among many other things, is, and it's very deep in the my relationship with the church, is the fact that from, I think, the mid-80s, John Paul II actually had a discussion with scientists. I think Stephen Hawking participated in a conference in the Vatican about the Big Bang Theory and about evolution. And the official position of the church is that the Big Bang happened and evolution is a fact. But the relationship doesn't translate, and here is the personal story.
I was going to say, so you're hardcore space dork, astronomer, but you grew up a Catholic.
Oh, extremely Catholic. But this is
Tell us more.
This is where things start deviating, and we're not even going to touch on the gay thing. I will just talk about the science thing.
20
yeah,
minutes,
yeah. I'll keep it snappy. So, picture this: Italy, 1999. So. It might become clear, or will become clearer by the end of this talk, I am a big nerd. And even when it comes to Sunday school, I want to have A+ in Catholicism, which is something that you think, oh my God, this is very not healthy for anyone to approach life at. You need to very best and you know everything. But that is very much me. So, I am helping post-confirmation in this helping like young people in church, because my mom been pushing me to do this and being more involved. And at a certain point, we're having a conversation about the universe and everything. And I always wanted, I wanted to be a scientist since I was 9, so I felt it was my bread and butter. And that's when the massive fight with the priest happened, because the priest refused to say, he said that the Big Bang doesn't exist, we were created, everything was created in 7 days, we come from Adam and Eve. And I'm just like, but that's not the position of the church. And I'm right, and I'm there, 14-year-old, thinking like, I am right, I've read the encyclical. I started studying Latin, I can read them in the original, like, I am right, and there is this priest that is just using his authority to just say, oh, no, I know more. And this thing, it's...
I like that you don't hold grudges.
Oh, no. So what is it, 22 years?
Yeah.
Oh. But yes, I still hate him. But...
Let it go.
Was not fun when he was the priest at my cousin's wedding, but it's fine. I should have with my husband, that was a conversation starter. So, yes, that is one of my major grudges, but that actually feeds on the confirmation bias, is this idea that we approach understanding of the universe and of everything, not just the universe, capital U, but everything around us, with prejudice, with preconception, and with just ideas that are false. And sometimes this confirmation bias blind us to the actual truths.
In a way that confirmation bias can work both ways?
No, because when we think that it works both ways, just like, oh, you see, I was right, like me with the priest. But it's often enough, we need to be, it's so important that we need to be aware of this. And to be, given that I'm going to continue to bash the Catholic Church throughout the conversation, let's give me a little bit of balance with making a comment about New Atheism, something very that happened lately. Richard Dawkins, with the poster boy on New Atheism, has recently reviewed a terrible book, very transphobic and anti-Semitic, and in that book there is this comment about how mammals are mammals because they give birth to live young, which is just like
other things like some snakes give birth to live young.
Yeah, but also you have platypus. How can you forget the platypus, the cutest animal in the world, or the echidna? And this thing is the confirmation bias. When you think you agree with a certain thesis, are you going...
Nothing else.
Yeah, are you going to ignore this blatant biology bullshit? And I kept thinking, would there be something that would make me think, would make me completely ignore my confirmation bias? So the closest thing that I thought was a book about how pizza is the best thing in the world. I think that is the only crucial thing that I could probably see. But at the same time, if somebody was claiming, oh, and you see, the pizza is the best thing in the world, and this is why the Earth is flat like a pizza. At that point, I would like, okay, no, we need to talk about that.
Why do all of your analogies revolve around pizzas?
Because
and
pizza is the
food?
best, and I'm Italian. That's where we boil things down. But this is crucial when we want to approach a discussion on understanding the universe and applying our lens. So if I approach understanding the universe and studying the cosmos, I would approach it as very much an atheist. I don't believe there is God. And maybe I could be missing something if I don't take into account that I have this idea that God is not out there. And at the same time, there's been scientists throughout the last ever that have approached it in the same way, but believing that there was God, a creating force, etc. You got a question?
I did, now it's gone.
Okay, I'll give you the example of the most famous scientist. You got a question now?
No, again, it happened. Sorry, carry on.
So, the most famous scientist that this happened is Albert Einstein. He believed the universe to be static. So,
in what way?
That the universe has always been and always will be.
Oh.
So the universe did not change. But he created his equation, was super happy with his equation, and other scientists start pointing out like, oh, that's really cute in your equation. The moment you start just adding anything in, the universe changes. And if you start going back in time, the universe just collapses into a singularity. And I'm like, oh, no, we don't like that. That is not supposed to happen. And his idea was just that I have no evidence to believe that the universe is expanding or contracting or changing. And everything in my culture has brought me up thinking that the universe is static. So he added this term that we now call the cosmological constant to make the universe static. Then in the 1920s, 1930s, Hubble proved that the universe was expanding, and it's like, okay, no cosmological constant, and so on.
So, a little bit of a curveball for you. So, as you were just talking about how you have to be very careful not to conclusively 100% say there is no God, because you're very aware that as a scientist, you would need empirical evidence one way or the other. Would that not go a little way as for you basically saying you are on some level agnostic?
Philosophically, yes, but...
That's a scientist, no, never.
No, the scientist, no, never. But it's, I think the point is we need to separate, I think, Alfredo the person from Alfredo the scientist. For the scientist, I like to think of an ideal scientist that is radical and skeptical and that can challenge things and yet be open-minded. It's a complex philosophical concept. Alfredo the person is flawed as grudges with a priest for 22 years, has his own preconception. So it's, I think, the discussion that I want to have is that there are definitely things that people enjoy putting meaning onto, and seeing divinity or seeing empty, careless, godless universe. I think people like to put meaning on things, and I want to make sure that everyone knows that we need to keep them you can put the meanings that you want, because at the end of the day is yourself, your philosophy. But at the same time, if you want to claim something, like a lot of people do, you cannot do that without coming clean of your biases.
So you talked about a little bit, you touched on what you feel like a scientist should be.
Mm-hmm.
And one of the things you mentioned, you were like, to be radical and skeptical.
Yeah.
Radical and skeptical would have been something that I imagine would have gone hand in hand perfectly in the time of Galileo. But because of the way everything has come since then, is there still room for scientists to be radical?
Even more so. But you see, there are so many examples, I would say, especially from the beginning of the 20th century, in which you could divide the scientists that were radical and skeptical versus those that weren't. And we see that repeating pretty much every 30 years afterwards. So Einstein and Planck and Marie Curie had revolutionized the way we see physics in terms of quantum mechanics and particle physics, etc. But they were considered radical and skeptical at the time. And then until the 50s, even the word Big Bang was considered, it started as mocking, because they didn't think that that could be the origin. And
it was just used as like a funny term.
Yeah, because it's Big Bang, it's a big explosion, if everything's compressed and then exploded. And you see, something that is fascinating, and again, we see the trying to put meaning when you don't know. Actually, there are three major problems with the Big Bang theory as it is in very simple terms, that you compress everything and things expand. One, it's very, very physicsy and complicated. One, it's about thermodynamics. When you look at the universe is pretty much the same all over the place. Wherever you decide to look, it sort of looks the same. And so they're like, okay, let's assume that this universe that we see now, as big as it is compressed all in a very small region. That region was too big to have all the same temperature. So when it expanded, you should have areas that are a little bit warmer and areas that are a little bit colder. But you don't see that. And that is called the horizon problem, because pretty much the area whose horizon weren't touching, and so should have different temperatures. Another thing is, so the universe, and bear with me, I will explain, is three-dimensionally flat. What does it mean? Something that no human can comprehend, because we see the world not in 4 dimensions. But let's think of this nice table is 2-dimensionally flat. So if you have 2 parallel lines, like you might remember from geometry, they never meet. Mm-hmm. But now let's take a curved surface, like the surface of the Earth. Let's go at the equator, something nice and warm. And you have 2 parallel lines there, and you draw those parallel lines, they're not going to stay parallel. They're going to meet at the pole, at the North Pole and at the South Pole. Those lines will meet. So that is when parallel lines are not meeting, that is flat. And you can have the same in 3 dimensions. So if I have 2 lasers and I shoot them into space and they will go on forever and they stay parallel, the universe is flat. And we think the universe is really, really close to flat. But because things tend to get messy and more complicated as it expands, if it's really close to flat now, it needs to be so precisely flat at the moment of the Big Bang. And what was one solution taught by many? That's the hand of God.
I was
Like-
going to say, like, there's so much going on that
It's just
even,
like-
even with the science, it almost gave the religious people fuel to be like, well, what other explanation could
But
there be?
It is very, in a way, a very elegant solution to his problems. Also because the physicists have a solution which is a bloody mess. It's called cosmic inflation. It is extremely complicated. I very much struggle with it, and I have a PhD in astrophysics. And what it pretty much says is, okay, let's pretend that for a fraction of a second, the universe just went boom. And I'm literally like...
As in the Big Bang, just...
No, after the Big Bang, for something that if you take the entire age of the universe, it would last less than a nanosecond in comparison, so something tiny. The universe just got even bigger than what happened with the Big Bang. That is cosmic inflation. And we have no evidence that that is what happened. We think that is the best explanation, but if somebody could argue that, like, okay, why is cosmic inflation fine, but saying God is not? And the only answer to that is because God is just a too neat of a solution. You don't have to ask more questions. While cosmic inflation is like, okay, but what does it mean? But what are the effects? What else do we know? I am pretty much like a 4-year-old. I want to know why a few more times than just the standard, why is the sky blue?
Okay, so going back to the big question of tonight as well, and drawing a little bit on what you just said, if God is too neat of an answer, what would be the best scientific approach in your mind to trying to prove the existence of a divine being?
There is one that I actually like because I think is a very scientific approach at trying to understand if there is a deity, and is looking for messages in the cosmic microwave background. So, what is the cosmic microwave background? Is the echo from the Big Bang. So, imagine back in the Big Bang, everything is very hot, and it's very, very hot for about 380,000 years. It is so hot that it's pretty much a soup of light. That is how hot it is. But at that point, it's getting cool enough that atoms can actually form, and this light is finally free. And this light is the biggest evidence that the Big Bang happened, and it's everywhere around us. If you have an old television set, about 3% of the noise that you can put on, or even just a radio, about 2 or 3% of the noise that you get from that comes from photons that were emitted in the Big Bang. Fantastic. And that one is visible everywhere in the universe. So, if you need to hide a message for your creation, just to say, hey, I made you, or like
it would be like a
copyright
sort of, yeah, it's like a signature in space.
That would be, and there's been both theoretical papers and actual studies looking at it, and I appreciate those because there is not like saying, oh yes, it's gonna be there, or oh, that is a solution. That is like a scientific question. Is like, is there a message? Could there be a message? Would be able to understand such a message. So.
Okay. I have one last question for you.
Go for it.
And as usual, I like to spin things on the head when it comes to you because it makes you awkward and uncomfortable. If you had to act as devil's advocate,
Going back to
good
the Catholic
phrasing,
Church.
yeah, to find proof of the existence of God, what would you pick?
Okay. Again, this is probably going to give such an insight in the state of my mind, but I would make God uncaring and actually quite mean. And the proof of the existence of God would come to the fact that a butter toast always fall on the...
Again, food. Again, food.
Again, food. But I will explain why. Because the reason you can... first of all, it has been tested experimentally in the UK. I think it was in 2002. And 60% of the time, a butter toast would fall on the butter side. So it's just like, this is statistically significant, and it was done in schools. So this is fantastic. But there is a theoretical explanation, and it connects the butter toast to the fine structure constant, which is one of the constants of the universe. And it is the reason why we are here today, because the fine structure constant pretty much determines how atoms interact. In particular, we'd see how they make other atoms, stars make other atoms into everything else. So with nuclear fusion, they turn hydrogen and helium, in carbon, oxygen, everything, and then other stellar processes create the heavier elements, and here we are today because we can either interpret it as we are made of stardust or we are walking, talking nuclear waste from star. Either explanation works, whichever, if you want to be more poetic or more metal or more punk. So that fine structure constant pretty much determines the possibility of life in the universe. But when it comes to human being in particular, also determines how tall a table can be. Because human variation in terms of height, from toddler to the tallest person that ever lived, is pretty much determined by evolution, in a way that if we have a fall, our skull doesn't crack. So is how good the calcium in our bone can stick together, determined by fine structure constant. That gives the possibility of tables on the planet to be only in a certain range. And in that range, a butter toast that gets flipped can only do a certain amount of rotations. So the reason why life is possible in the universe is connected why the universe, or maybe God, doesn't like for floors to be clean and to be able to save your toast. And I think
wow.
if there is a God, they better have a very good excuse for having created that kind of rule in the universe.
Okay. Wow. Okay, I was gonna. Yeah. I guess we could just wrap up and say, is there anything like a big takeaway message from everything that you just ranted about?
Wow. Big takeaway message. No.
A quick one.
Little takeaway message is it's important to be curious. It's important to understand our own biases. It's important to keep asking questions, even when the answer leads to butter toast on floors. And I think it's very, very important that we, even when we are very convinced that something is true, we entertain the idea, even just philosophically, of the very opposite.
Thank you.
Thank you very much.
It's been really good.
Is there still a relationship in the modern day between astrology and astronomy?
Is there still a relationship in the modern day between astrology and astronomy?
No. None whatsoever. It is very interesting for as much as, again, to be completely honest and upfront about my beliefs, astrology is absolutely made up nonsense. At the same time, for many centuries, I had collected so much data that actually some mathematics and some data science today is actually based on astrological calculation, astrological formula that were being used in astrology up to the middle of the 20th century. So you might, like, there is no connection with astronomy, but there is quite enough connection with, like, economics and stuff. So you can interpret that how you want. Yeah?
Yeah, this is a rhetorical question to start with. Have you read Hitchhiker's Guide to the Galaxy? And do you remember God's last message to his creation? Sorry for the inconvenience if you don't know it. Right. To quote Carl Sagan in his book Contact, again, probably a rhetorical question, have you read that one? At the end, the aliens give Ellie proof of something, and that proof is a shape within the digital, the decimal places of pi. I think it's base 11, I think it was, to remember, I thought it was. What, you know, on a more serious note, that to me seems more likely to be a message from God, in inverted commas, than anything else, including your excellent example of toast.
I can't
So-
repeat.
So we had a lot of, actually two fantastic sci-fi examples of messages from God. One was from the Hitchhiker's Guide to the Galaxy. So when that study came out, I think it was December last year, I did a little, not animation, a little drawing of the cosmic microwave background and literally wrote on top, we apologize for, or sorry for the inconvenience, which I think it's brilliant. It's a brilliant message from God. And the stuff about Contact is that there is a message from inside pi. Pi is another thing like the cosmic microwave background. No matter where you are in the universe, no matter how you were going to approach it, even if you don't have anything to create a circle and a radius, pi will pop up in all your physics and chemistry and biological equations. It's always there, and it's a fascinating number. I can tell you this, think about your birthday, your birth date, and think about the birth date of somebody you care about. Inside pi, those 8 numbers, those 16 numbers, so those two sets of 8 numbers, will be one after the other, like that, at some point. It's simply because the number is infinite, so every combination of numbers that you can think could be there. So, if there was a message, that could be a good place to look. But we need aliens to tell us exactly how to look, because it's a really big number. So.
Well, I think that with the degree to which humanity has evolved and we are questioning our very existence, are we cosmically significant?
Are we
Could the
cosmically
mind be
significant?
considered omniscient? Or are we? Because there's no bounds in human imagination, really.
I would like to take this.
Okay, Chris takes the question about are we
cosmically significant? I personally would say no. But so what? Also, I think life is what you make it. You keep scrunching your face up. But no, I don't think so. I mean, if we were cosmically significant, then doesn't that lend itself to a very spiritual point of view? That we matter on some cosmic scale. We're like microbes on the back of ants. We've been spoken about.
I don't think it matters that we are specks of carbons on a speck of silicon in the not fashionable side of the Milky Way. It's we are apes. We should be in the savannah scavenging. Instead, we're here wondering about the greatest mystery of the universe. It doesn't matter if we don't have a long-lasting impact, because in my views, like, the universe eventually will end up in an entropic heat death, and nothing will matter. But the fact that for this instant we are here and we are pondering this question, that we are here and I don't know, we are falling in love, making art, singing, dancing, whatever, it matters.
It matters to us, but not on a cosmic scale.
I think it matters on a
It's
cosmic scale.
significant to us, and we hold those values dear in our own life, in the short existence we have. But
Life is what
so
you make
it's
it.
subjective. The universe carries on regardless.
Yeah, but I still think they were significant. Please.
Yeah, there's just the interesting point in terms of when you actually think about how big the universe is. When we talk about the universe, we're only talking about what we can currently see. And you were talking about Guth and the expansion. So I think if he worked out his theory, he said that if you believe that the universe is much bigger than what we can currently see, I think it's something like 1 to the 16 million times or something. I can't remember, it's some ridiculous number, sextillion times or something. It's like 16 zeros in it, in terms of how much bigger the observable or the non-observable universe is. So when you think about how much smaller, even how big the universe is, how small it is compared to what else is out there. But the point about it's interesting your views about what we think about ourselves, because we don't, whilst we're part of it, we don't necessarily need to be vital or play any part in it at all. If the whole of the Milky Way were to disappear right now, it wouldn't make any difference with it to the universe as it is.
It would not make any difference. If the flatness problem that we discussed, if the universe is truly flat, there is a possibility the universe is infinite, which is because at that point you're like, okay, but how do you explain, you have the singularity of the Big Bang, I can picture that, yeah, everything is in a point, but how can that point also be infinite at that point?
I don't like that.
Yeah, you don't like that the universe is infinite. It's fine, we don't know. If we take the visible universe, everything that we can see, because obviously we see things that are 13.7-ish billion light years away due to the expansion. The visible universe is today currently around 46 billion light years across. A huge number. And yes, even our Milky Way is a tiny drop. And if it disappears, doesn't matter to anyone apart from the creatures in the Milky Way. But I still think that even though we are so tiny, even though maybe we will matter in the scheme of things, maybe we need to be optimistic about humans' possibility in the future, that we're not going to make ourselves extinct over the next 20 years with the climate crisis. Maybe we will find solution, we will explore the universe in phenomenal ways and be more significant, but I think we are significant right now. Lots of questions.
Have you, because obviously Catholicism has got a very negative history in recent periods with science, have you encountered any religion in your life that you think goes hand in hand with science, or has been working alongside science in rudimentary ways over history?
Are there any religions that go hand in hand with science?
I think it's not a question of religion, I think it's a question of power structures, which obviously religion fits into. But we can see that while a lot of scientific investigation, mostly when we talk about science, we talk about modern science from Galileo onwards, but there is scientific investigation since humans have been walking onto the planet. And if we want to consider more formalized stuff, while during the Middle Ages in Europe, there was phenomenal advances in astronomy and medicine in the Middle East. And it was just because Arabs ruler felt that it was very important to finance science and knowledge. So I don't think that religion is per se something that stops science, but it comes down to the power structure. Is science ideally, again in the ideal scientists, can easily question who holds the power. and we're seeing it more and more nowadays, how some things that we have assumed to be true even in a scientific and science, just like religion, is a human thing. So, victim to the structure of powers, we see things that have just been assumed to be true that are not the case, and simply because the people that had the power in science were biased. And one really easy example is the belief that women have different symptoms when it comes to heart attacks. And it's because most medical stuff throughout history is done by men, on men only. And so like, women, who cares? So like, sure, I'm sure that we'll sort it out eventually or something. And this thing, it's, again, if there's, I think, historically plenty of example of science and religion coexisting perfectly, is the fact when it comes to power dynamics that things get problematic. And obviously the Catholic Church, my personal experience, doesn't want to share power at all. Okay, many questions.
One in the back row.
Okay. Yeah?
Yes. Isn't a lot of the discussion and the way to get at the questions that you're raising really the realm of philosophy as distinct from science? So, for example, it strikes me that one key question really to do with the relationship between any God, if there was a God, and the universe is the problem of divine agency. How does something that classical theism has defined as completely spirit, utterly non-physical, how can it even be conceived to interact with something that is physical? So it's not, I mean, you know, the response, oh, well, God is omnipotent and so God can do anything, doesn't really work, because unless you go with Descartes, who believed that, you know, omnipotence meant God could be logically impossible, one is left asking, but it's not actually logically possible, because one can't even imagine how it will be possible for an utterly non-physical agent to even interact and therefore have any effect on the physical. And isn't that kind of question really at the heart, that philosophical question at the heart of this sort of debate?
Absolutely.
That was a fantastic question. Do you want to repeat me to repeat the? Okay,
go ahead.
Pretty much is a discussion of science and philosophy, and if there are aspects of what are one of the examples is the spirit and how it
could possibly affect the physical realm.
Yeah. So. Absolutely, I agree with you 100%. We are struggling the line of science and philosophy with the entire talk. But I think I need to be devil's advocate again for religion. So, I don't think even if we could find an existence of a creative force in the physical realm, I don't think that it's a God in the way we understand through religion. If I need to think of Catholicism again, I cannot think of a God that has 46 billion light years worth of universe and is looking down and thinking, you shouldn't masturbate. Is that the best that a perfect intelligence can do? Like, come on. So, the question is, could there be any kind of interaction in our universe that goes beyond our universe? And it is possible physically, like we know, well, in the theories that try to bridge quantum mechanics and general relativity, like string theory and quantum gravity, they suggest that gravity might be able to escape our universe. Cosmic inflation that I mentioned earlier is created by a field that we don't really understand yet and only acted for a very brief instant after Big Bang. And dark energy whatever that is, because we still don't know what that is also, I believe, mediated by a certain field. So there could be stuff out there that we don't know, and there could be something that comes from beyond a universe where there is a creator that gave the spark or gave influence. I don't believe that there is something that could create a soul or give anything into that make us us. And I would happily stake my life on it. But at the same time, I need to approach that question by saying I don't believe that is. But I cannot say that scientifically we have proof that there is no soul. But on the other hand, given that it's a philosophical discussion, proof is on the people that makes the claim. So if you claim that there is a soul in all of us and it's perfectly pure and it will be ascending to heaven, apart from those of us that are going back to straight to hell, is like you need to approach it you need to provide the evidence for it. It's not up to us. Okay, two more questions.
So mine is slightly different. So I don't know if anyone's seen Annie Hall, and it starts off with him saying, going to the doctor, and his mum says he's depressed because the universe is expanding and expanding, and actually he just really can't deal with it. My kind of question is, kind of two questions. I'm a psychiatrist. How do you explain this sort of stuff to normal people without them feeling like they're going crazy? In a really straightforward way, because it's the humanists, and we're going to be competing with people that communicate in very simple ideas and actually tell and give people really simple answers. I love the explanation of the slice of toast. I thought it was amazing. But my question is, how do we, try to, I'm kind of interested in how do we communicate these ideas and think about it in ways that don't make people feel like that scene of Annie Hall, where they hear that the universe is expanding and suddenly they just combust. They go crazy. It's like 12 or 13-year-olds. And I'm talking about the limits of our understanding and kind of perception and kind of reality. And how do we deal with that?
Very, very good question. How do we deal with the fact that we're very tiny and there's a huge expanding universe out there? The first part that I want to say is I think it's important that we talk to people about the complexity of reality. I think we're getting way too used to approach everything in very simple terms. Things are black and white, people are either perfect saints or terrible, awful people, and we are not dealing with grayscales, and we need to deal with that. For the particular of how do we deal with death, I actually have an example from 2 nights ago. My parents watched a documentary on this black hole inside a big galaxy that is surrounded by, they estimate, 1,000 galaxies. And my dad was like, talking to me, and I was like, yeah, all of this is how it works. I'm like, that's too much. That is too big. Because the black holes is, if our estimate is correct, is 63 billion times the mass of our sun, which is already huge compared to us. And you're thinking something that's 63 billion times, and still it wouldn't be much bigger than a solar system. And so you're thinking something that is so heavy in a space that relatively so small, and it's literally, you're just like, okay, no, I cannot deal with this. That was my dad. And very interesting question, a very interesting reaction from my mother, because dad was like struggling there, and mom was like, but how do we know that all of that is correct? And I'm just like, that is very good skepticism, and we know that is correct because we do multiple observation. And I'm just like, and mother, maybe you should bring that energy next Sunday when we go to church. And you know what she said? They're like, you know what? oh, you're absolutely right. Why should I trust what is in the church? I'm like, I'm making an agnostic out of her. But I think it's important that we discuss complexity. And like I have a friend that he loves to hear me talk about space, and it just asks, don't tell me the size of things. Tell me about fun galaxies stuff. My PhD is galaxy collision, so tell me about that. Don't tell me how big or small things are. I don't want to know because that will freak me out. So he knows that things are big, he just doesn't want to know the details. Last question, go ahead.
In a universe that's completely governed by, or to my knowledge, completely governed by physical forces and inanimate physical atoms, do you believe there's a good argument to say that our lives are determined and that the universe is determined and that we don't have any free will?
Wow, so for the last question, it's, we are...
So everyone's going home at like 11 o'clock.
Yeah. No, I will make my point actually, I will make two different points on the subject of free will. So, first one, psychological. We don't understand consciousness. We sort of getting at what consciousness could be, but we can see it as the sum of our experiences. So, psychologically, I would like to think that there is no free will, simply because I like to think that I am self-consistent, that my choices are not because of a random flip of a coin somewhere in a multiple phenomenal multiverse or something. It's just because if I want to drink this glass of wine, it's because I like wine, I am thirsty, I'm going to drink this glass of wine. And this is my psychological argument for saying no free will. There is nothing to do with like predestination or anything. It's just about me as a human. When it comes to everything that is atomic and works with us, then we have quantum mechanics, and literally, God knows how that works. It's I have a master in theoretical physics, and I've always been fascinated by quantum mechanics, but it's literally everything that you expect from your day-to-day experience, it's not. And probability, the fact that things might happen or not happen, it's just a fact of the universe. That is more of a fact of the universe of what we see, that like that the glass is there and it's physical. Einstein, because you see, talking about the fact that the biases, etc., Einstein hated quantum mechanics and probability. He was certain that the universe needed to be deterministic because that was his vision of the world. So he said famously that I like to believe that the moon is there even if I'm not looking at it. And that is, yeah, because at our size things become sort of deterministic, but ultimately things are only based on quantum mechanics. And we still don't understand exactly all the effects, because quantum mechanics, which explain the very small and all those interactions, doesn't work with relativity, which explains the very massive, and you have some overlaps on the very fast, but then you get to things like the Big Bang and black holes, and suddenly everything is utterly broken, and it's fascinating. And it is fascinating because we are, so often when we talk about science, and it's on our science communicator, we make it feel like, oh, we know so much, but instead we know so little, and we are in such an exciting time to know so much more and find more exciting things. And our view of the universe could be revolutionized in the next decade. And here we're here discussing things like, oh yeah, we know so much, and invite me back in 10 years and it's just going to be, oh, things have changed, hopefully for the better.
So we have we have time for a few more questions,
okay.
If anyone else has questions.
Okay, so this is more of a question about your sort of interactions with religious people, your family, members of the Catholic Church. So it is pretty normal for religious groups or individuals to take aspects of science and try to say that they prove certain aspects of their religion. So with young Earth creationists, the Grand Canyon, and the fact that there are rock layers, the Big Bang, the fact that it was a definitive start to the universe was used as evidence that, okay, in the beginning God said, let there be light, Big Bang, explosion, lots of light. It's kind of weird. So one of the sort of ways that I thought would be an obvious way to look for God in reality that I've never heard before, and I'm curious if you have, is the discovery of the little green men signals, the quasars.
Little green man is pulsars.
Pulsars, sorry, quasar
Sorry?
galaxies, aren't they?
Yeah.
Yeah, so yeah, the radio signals from pulsars as sort of a way to potentially look for a signal from God. The radio emissions from pulsars would seem like a pretty obvious one, and I don't know if you've ever come across that.
I never come across that, but so if you can give me a little bit more details, and I'll explain what pulsars are. Or is that what you know about that?
So far as I'm aware, pulsars are very quickly spinning neutron stars together.
That is absolutely correct. But how does that prove God exists?
So more in the way of like looking in pi for a particular message.
Oh, okay.
The CMBR.
I have never heard of that. So, pulsars. When neutrons, stars first. You have big stars between up to 8 solar masses, so a little bit bigger than the sun. When they go explode supernova, they collapse into this very dense object called a neutron star, which is, we think, between 10 and 20 kilometers. So, something the mass of the sun in the size of a small city. And because of conservation of angular momentum, which are like, what the hell is that? Think of a spinning ice skater. Spinning ice skater, they're being super slow with their arms wide open, they close their arms, they start spinning fast. That is angular momentum. Is this quantity that is conserved. So a star is rotating, the Earth is rotating, has angular momentum, but if you compress it, suddenly the star spins faster because the angular momentum needs to be the same. And when it happens and they start emitting jets of radiation, those are called pulsar. And they appear like very fast pulsating stars. It can be spinning up to several hundred times per second. Joyce Bell Burnell, astronomer, British astronomer, she discovered the pulsar as a joke. It was never taken seriously. They wrote the LGM, Little Green Man, because they saw a signal. She didn't win the Nobel Prize for that because she was a woman, so her supervisor got the Nobel Prize for that. But she said that she's happy because she got a lot more opportunity with it. Still, should she be recognized with the Nobel Prize? Anyway, rant aside, pulsars are very important because they are some of the most precise clocks in the universe, and they are being used even to study gravitational waves from further back in time than the CMB. So the cosmic microwave background that we encountered earlier is the further back in time we can see with visible light, with any kind of light in the universe. But gravitational waves can go further, potentially even very close to the Big Bang, potentially even close to the cosmic inflation, and we find out if it's true. So, if there is a message from God, you could potentially, okay, I'm assuming, I'm just going, Alfredo, you're omnipotent, you have power through all of universe. Oh my God, I should not be given such power, but I decided not to do anything bad or evil. I'm not going to fix the butter thing. I am just going to organize stars in a way that they collapse. I think you can you could make a sort of okay message, but I think something like the CMB, like with the pulsars, you will have to do the same for every galaxy that you expect to have life. So you need to create all these pulsars that are sending all this pulsation and creating a message. I think it's a lot of work. But again, if we're going with Catholicism, is a God that cares about masturbation over 46 billion light years, so just like, okay, I might make some stars and see what happens. But I think the CMB or pi, as we discussed, is a much easier way. I don't know. I don't know if in this scenario God is very lazy, and so we're going for the simplest thing.
Well, if God is truly omnipotent, then any action takes an equal amount of effort.
Good question. Now you see back in philosophy is like, if somebody is omnipotent, can they be lazy? Okay, I don't have an answer to that.
Hi, could I pull you back to dark energy?
Yes.
Please. And so I think this goes back to what we were saying before about things that are beyond sort of our normal dimensions and how we can use scientific principles there. My understanding is that dark energy or dark matter is about 60-70% of the mass energy of the universe. But we can't interact with it. We can't experiment with it directly, which is a problem for scientific inquiry.
Huge.
And similarly for the M-brain theory or M theory, where there are other dimensions in universes that are apparently interacting with us and could cause big bangs or other events in our universe. But again, we can't experiment directly with it. Can you talk about some of the latest thinking about how physicists are working on it?
That is, everything that you can see and touch, so us, the platypus, stars, planets, anything, is about 5% of the universe. In the 1970s, Vera Rubin, another woman that didn't get a Nobel Prize for her discovery, proposed the presence of dark matter around around galaxies, simply because galaxies rotate. So you might have seen a picture of galaxy with nice parallels. If a galaxy were just spinning, and we're going back to food, you can just picture. So you're making a cake, you're adding chocolate.
Pizza, please. Let's stick with the pizza.
Yeah, and you start spinning. The chocolate will first form a spiral, like the spiral galaxies. There is a connection, but then it will all become chocolate. You're making a chocolate cake. So how do galaxies keep the shape for billions and billions of years? And the idea is that there is so much matter around galaxies that it sort of keep them in shape. And that was called dark matter. It is not really dark, it's invisible. It doesn't interact with light, at least we think. There are some potential interaction, and in this potential interaction, there are few experiments that are being placed under mountains with huge detectors that can maybe see one interaction of dark matter when it's very rare that hits something that is not dark matter, something that is made of a regular matter. Once that was put in understanding cosmology, they're like, okay, there is a lot more matter than we were expecting, so the universe will stop expanding at some point and will collapse on itself. That was the big crunch. And then in 1998, they realized that the universe not only is expanding, but it's expanding faster than it should be expanding. So how do you explain that? With something that is pushing the universe apart. And if you remember from earlier the mistake of Einstein of having the cosmological constants, the thing that is making the universe expand looks very, 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 very similar to what Einstein had to put in to make the universe static. It's on the other direction, so to make the universe expand faster, but it is very similar. So that's back in. And because we don't know if it's a cosmological constant, so something that is everywhere in the universe, or is something that changes in different places of the universe, we call it dark energy. And dark matter is about 25% of the matter energy content of the universe, and the rest is dark energy. And this is our understanding. What we know, and is the latest
So you said that we can experiment on it. You were saying some of the under-mountain sort of particle...
We hope that we can.
We're not sure.
Hope,
we're not sure.
So we're hoping that we will see a dark matter particle hit something and we'll say, haha, we know now the dark matter we caught you. That is far away from, we can experiment on that. But what is very exciting is what's going to happen in the next 5 to 10 years. There are several observatories coming online that will take huge amount of observations, and that will help us understand the universe better and these two major components. To add things to the more complications, there is currently a big schism in astronomy, because the way we measure the expansion rate of the universe, depending on what kind of thing you use, you get two different numbers, and astronomers are getting, it's hilarious, to be honest, as a science communicator I find it so much funny because they get so angry and I don't have to do active research anymore, and it's always like, oh, we have tried this new method and we found one number. And I'm like, yeah, but that other method is pretty good, so why so? And they are very close, but statistically, they are two different numbers. So either we are measuring things wrong, which is a possibility, we're humans, we make mistakes, or our entire understanding of how dark matter, dark energy, and the whole of cosmology needs to be completely updated. So, next 5 to 10 years, exciting times in astronomy and cosmology. I think that is it. Awesome. Thank you very much for listening.